Okay, so we're on unit 10.5, or 10.6, excuse me. Okay, we're on unit 10.6, and this is just more probability. So basically today, we're just going to mix up all the different kinds of probability and make sure that we know what to use when. Okay, so the first kind of probability we learned was the fundamental counting principle. Okay, remember, fundamental counting principle was just when you put the number of spaces, okay, number of choices multiplied by number of choices. Okay, that's when you do the lines. You should use the fundamental counting principle when logic seems best. Okay, use when logic seems best. Okay, so something like number of choices multiplied by more number of choices. Okay, use when logic seems best. Okay, next thing we learned was factorial. Okay, and remember, to do factorial, all you have to do is multiply all smaller integers together. Okay, remember, integers are whole numbers. They do not include 0 and do not include negatives. So multiply all of the smaller integers together. Okay, then we went over permutations. When should I use a permutation? Permutations are for what? When order does matter. Right, when order does matter. A couple examples of when you should use permutations are in spelling. Okay, spelling, in races. So something like if you're getting a first, second, or third place. And then also in ID numbers. Okay, so that could be social security numbers, phone numbers, okay, ID numbers, unique numbers. Okay, so unique numbers. The formula for permutations is NPR, and that is equal to n factorial divided by the difference, n minus r factorial. Okay, this is the one that the formula is smaller. Okay, you don't have quite as much to do there. Next thing we went over was spelling with repetition. Spelling with repetition. Okay, and when you do spelling with repetition, you need to take the total number of letters, factorial, total letters factorial, divided by each repeat, factorial. Okay, so that means if you have two different letters that both repeat, you're going to have to write two different factorials in the bottom. Okay, so not the total repeats on the bottom, but each repeat. You have to write them separately. Okay, so total number of letters, factorial, divided by each repeat, factorial. Next, we went into combinations. And when should I use combinations? When do we use combinations?
Community. A committee.
When order does not matter. When order does not matter. Okay. So yes, an example of when you use combinations is commonly when you're finding or when you're forming a committee. Okay, that's the most likely time when we use them. Okay, is forming committees. The formula for combinations is NCR, and that is equal to n factorial divided by r factorial multiplied by n minus r factorial. Okay, so that is the larger one. You actually get smaller answers with combinations, but its formula is more complicated. Okay, next thing we went over was probability. What should you always get if we're finding the probability of something? You should always get a fraction, exactly. Okay, so on your quizzes today, you're gonna take two quizzes, okay? If it's asking you what's the probability of something happening, you need to make sure that your answer is a fraction, okay? has to be a fraction. If it's asking you about how many different things could happen, that's a combination or permutation. Okay, but make sure with probability that you're always writing answers as a fraction. And the formula there is what you want, or the outcome that you want, what you want, divided by total possible. So the outcome that you want divided by total possible outcomes. Okay, what you want divided by the total possible.
When's our test on this?
Your test on this is next week on block day. So not very much longer. Okay, and we are also doing a task on Monday. Okay, we're doing not the ferret task, but something like that. Okay, so we're not going to do anything new on Monday, but we are doing an activity that will take all of the period. Okay, the next thing that we learned about was the probability of something not happening. Okay, probability of something not happening is always equal to 1 minus the probability that it will happen. Seems very obvious, but people tend to mess this up. Okay, so the probability of something not happening is equal to 1 minus the probability that it will happen. Okay, these are complements to one another. So it's like, what's the probability that will rain? Well, it's 1 minus the probability that it will not rain. So they always equal 1. Always equals 1. Okay, and we also learned about overlapping events. Okay, overlapping events. And overlapping events, the formula for that is probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so an overlapping event is something like, what's the probability of me, if I picked one name in this class, that it would be a girl or a sophomore? Okay, that means I would have to add up all the girls plus all the sophomores, but then I need to subtract the girls that are sophomores. So you would have to subtract the overlap, okay, because I've counted a bunch of people twice. Okay, so probability of girls plus probability of sophomores minus the overlap. Okay, next thing we learned about was independent versus dependent events. Okay, independent events. Okay, and something is said to be an independent event if the results are not affected. The results are not affected, thank you, by each other. Okay, so if the probability of one thing is not affected by the other. So an independent event would be like, I had a daughter the first time I was pregnant. That is independent of what I will have this time. Okay, they are not related at all. So independent events are not affected by one another. Those are also known, independent events are also known as with replacement. Okay, if I put something back, I am not decreasing the denominator. Okay, so with replacement is also considered an independent event. Okay, then we went over dependent events. Okay, and dependent events are opposite from independent events. That is when the results are affected. The results are affected by what has already happened. Results are affected by what has already happened. Okay, so that is considered without replacement. Okay, so for instance, if I take, if I have a bunch of marbles and I take one out and I do not put it back, the next one I pick is a dependent event because your denominator changes. Okay, it's going to become less. So that's the difference between independent and dependent events. So with replacement and without replacement. Okay, we're almost done. Couple more things I want to go over is, what does the word and mean? What does and tell you to do? And tells you to multiply. The word or tells you to do what? Add. Okay, and means multiply, or means addition. And then the last thing we went over was conditional probability. Conditional probability. So something like when you have, when you're getting a job, okay? Your job prospects are probably conditional on if you have a degree or if you do not, okay? So conditional probability is the influence of one event on another. The influence of one event on another. And its formula is probability of event B given A, so that's that big line, B given A is equal to the probability of both A and B divided by probability of A. So it's always divided by the second one. Okay, so probability of A and B divided by probability of A. Okay, those are all the different concepts we learned in this unit. Okay, so all together there for you. You do have homework tonight. Your homework is going to be worksheet 6. You are doing numbers 1 through 18. Okay, worksheet 6, numbers 1 through 18.